Over half the SAT math section can literally be solved with Desmos, like start to finish, barely even thinking about it. College Board actually handed you a calculator that can graph anything, and some of y'all are still out here complaining. But let's be real with something. You don't need another 1 hour long Desmos guide. You need one that you can literally watch on your way to the testing center on test day. So this is every single thing Desmos does on the SAT. As a quick note, this is still a full guide, just shorter. My mission with this video is to cover literally as much as possible in as short of time as I could. But if you do want a full Desmos course taught in depth with practice problems, I have a free one linked below. Just check it out. Okay, let's start with the basics. To access Desmos, search SAT Desmos or just open it in Bluebook. Desmos is a graphing calculator that can graph pretty much anything, and it can hand you intercepts, intersections, and the maximum or minimum, aka the vertex, automatically. If you type in a decimal, there's a fraction button to convert it into a fraction. There are also built-in functions that can save a ton of time. Mean, median, standard deviation, min, max, distance, midpoint, percent, greatest common divisor. All of those are functions. And for roots, type sqrt for square root, cbrt for cube root, or nthroot for nth root. Here's one thing that will save you some points as well. If you're doing anything with trig, aka SOHCAHTOA, go into the settings and make sure you're in degrees mode, not radians. If you don't do this, you'll be more cooked than somebody who ate at Taco Bell in the last 3 weeks. Next, sliders. If you said any letter that isn't x, y, or e equal to a number, you will get a slider that you can drag around on the screen. And if you type an equation with some undefined letter in it, Desmos gives you an add slider button automatically. This is great for finding what value makes a graph pass through a point. You can just slide the number around until the functions finally intersect. Another important thing is functions. Function equation problems are basically free points. All you have to do is set f of x equal to some equation, and f of 2 just plugs 2 in for you. If you type f of x plus 2, or literally any transformation, Desmos does the whole thing for you as well. No need to memorize anything about transformation rules in the big 2-6. And this works for any letter like g of x, h of x, anything. Now onto the big stuff, equations and inequalities. For single variable equations, aka equations with just one variable, graph it to get vertical lines. Those lines are your solutions. And if no lines show up, split the equation. Left side equals y and right side equals y. And then your solutions are just wherever they cross. For an example, you can try this one. For systems of equations, aka two equations, graph both and wherever they cross is your solution. If they cross at every single point, there are infinite solutions. If they cross at 0 points, there are no solutions. Here's another one. Inequalities are the same, except you get a shaded region for each inequality, and the double shaded part is the solution. So if your answer choices are points, plug each one in and see which one lands in there. And if it asks for the biggest or smallest possible value, click the highest or lowest point inside that region. Be careful because that's not always the intersection point. Also, watch the line. If it's dash, it is not included in the solution itself. If it's solid, then it is. To make it solid, just add an equal sign instead of the inequality. Here's a problem on this exact thing. Okay, onto regression now. This is the big one, and honestly it feels a little bit illegal because it solves a huge chunk of the math section on its own and means you don't have to do algebra, which, let's be real, is the whole reason any of us are even here in the first place. Regression is the squiggly line, aka the tilde. It estimates the value of any undefined constants, like letters, so both sides of an equation equal each other. The catch is it doesn't work for x or y, so anytime you've got an x, add a 1 after it to make it x sub 1. Same thing for y. The format is kind of insane. You just type the equation exactly as it's written, change x to x1, swap the equations for a tilde, and Desmos just gives you the answer with no graph required. The big reason why you'd ever want to use regression in the first place is if you ever have more variables than you have equations. So if you have like 3 different variables and only 2 equations, that's a good indication that you should do this. In addition to this though, you might notice that you can also use Desmos regression to just solve single variable equations like we showed before. It's basically just a faster way of doing what we showed before because now you don't even need to worry about the graphs. You're just given the answer immediately here. Now here's the part that most people mess up. If an unknown letter is a variable, meaning it can equal any number, you have to set that variable equal to a list. Just do 1 .. 10. If it's a constant or stuck as just one number, you don't have to do this. Turning it into a list basically allows you to count that one letter as multiple different numbers rather than just one. And with two equations at once, you can't do two separate tildes. It all goes on one line using brackets. You put the left sides of both equations in one bracket and the right sides in the other, with one tilde in the middle of it. One quick warning though, regression only ever gives you one solution. So if a problem asks how many solutions or no solutions, or the sum of solutions, do not use regression. You must split it into y equals each side and count the intersections instead, like I showed above. And you can also regress the mean as well. If a problem gives you an average and one missing value, you can just throw the unknown into the list and then regress it. If you get told that one letter must be greater than a certain number or less than it, like x1 must be greater than 0, you can just make squiggly brackets at the end of the equation in regression and put that in there directly as well. Here are a few problems on this. Table regression. Anytime you see points, and I mean anytime, you use a table. You just type table or hit plus in table and put your points in. Then there's an add regression button that fits a line, a quadratic, or an exponential right through those points. But sometimes the equation isn't one of those presets. Then you type it out yourself and turn it into regression format. These are the same 3 steps every single time: points, equation, and then swap to regression. And there are only 2 formulas that you actually have to memorize: the equation of a circle and the vertex form for a quadratic. Everything else will either be in the dropdown or given to you in the problem itself. Here's a problem again. Okay, on to some quick wins. If you see a circle, just graph it in Desmos. The radius is the distance between the top and bottom points divided by 2, and the center is the midpoint of those 2. And I do mean top and bottom, not left and right. Those are your x-intercepts, and they'll just give you the wrong radius if you use them, likely. Here's a problem. For which expression is equivalent problems, graph the first one, then graph each answer choice, and see which one lands exactly on top of the original thing. If a problem asks whether one thing is a factor of another, graph both and see if they share the same x-intercept. If it is the same intercept, then it is a factor. If it is not, then it's not. And for in terms of questions, set every constant to a different random number, not 0 or 1, and then test which answer choice gives you the right value. This is way safer than doing the algebra in your head, which is how you can very easily get a question wrong and never even find out. Just like I didn't find out about the Taco Bell until a day later. Okay, last thing, if a problem has an equation or expression or points, just go for Desmos as for how to solve it. Weird geometry and weird word problems are the ones that are more likely to be by hand. But honestly, you should just try to lean on Desmos as much as possible anyway, because using it on a problem that didn't need it is still usually faster than if you just do all Desmos problems by hand. It's better to make the Desmos mistake than the by hand mistake. And like I said, if you want any of this actually taught in depth, the full free Desmos course is in my community. The link is right below. This video is just for getting all the core information into your head. That's where you really can learn this stuff better and actually practice it. Because without practice, none of this is going to stick for the test anyways. Okay guys, good luck on the SAT. I'll see you in the next one.